electric flux. ID is displacement current. Then we discussed Maxwell Ampere's law. By dt. Then, so we discussed not only this, in so this is first point, this is second. So time varying magnetic field produces electric field, and time varying electric field also produces magnetic field, right? So we know that stationary charges produce electric field, so stationary charges are the charges which are at rest. That means this charge's velocity is 0. Suppose you have charge q, this is charge q. So at a distance d, it creates electric field E is equal to 1 by 4 pi epsilon naught q by d square. So here velocity of this charge is 0. So we call this charge as stationary charge. Then so charges in so uniformly moving charges produce magnetic field. So this is a wire. Let's say we have current I in this wire. Okay. So what is current?
Rate of flow.
Rate of flow of charges.
Charge. Very good. So in this wire, So these charges move in this direction with uniform velocity. I can say it as Vd. Okay. So current is nothing but, steady current is nothing but charges in uniform motion. Okay. So current is charges in uniform motion. So due to this wire, since there is a current I is flowing in this wire generates a magnetic field which is given by B is equal to mu naught I by 2 pi r. Okay. So meaning of this sentence statement is a current carrying wire produces magnetic field. Okay. Now so can I say that in this case, are the charges accelerating? This case. In this case, are the electrons accelerating?
Yes, sir.
Okay. See. So uniform motion means velocity is constant. Velocity is constant. If velocity is constant, acceleration is
0.
0, right? So in this wire, charges are in uniform motion. That means velocity is constant. So the acceleration of charge in this case is
0.
0.
very good. Acceleration is 0. So in this case, we have steady current and the acceleration of the charges is 0, right? 0. So what happens when the charges are accelerated? Okay. So what happens when charges are accelerated? So when the charges are accelerated, so a charge produces electric field, right? So what happens when the charges are accelerated? So oscillating charges. So oscillating charges produce oscillating electric field. Stationary charges produce electric field. Oscillating charges produce oscillating electric field. So see, we can see that electric field, time varying electric field produces magnetic field. So here oscillating electric field produces oscillating
Field. Magnetic field.
Yeah, oscillating magnetic field. Once again, oscillating charges produce oscillating electric field. Oscillating electric field produces oscillating magnetic field. So simply I'll try to define what is oscillating. See, this spotlight is a charge. Okay. So this is a point which I will call it as mean position. So if this charge moves like this is called as oscillating charge. Is it clear? It is moving about a point, so it is called as oscillating charge. So oscillating charge produces oscillating electric field. Oscillating electric field produces oscillating magnetic field.
Field.
Yeah. Again, this oscillating magnetic field becomes source of oscillating electric field. Again, this oscillating electric field becomes a source of
Oscillating magnetic
Magnet.
field.
yeah, oscillating magnetic field, and this happens so on. Okay, so again oscillating magnetic field becomes source of oscillating electric field. So here this oscillating and electric field and oscillating magnetic field regenerate each other. Okay, and they keep on regenerating each other. So
Last page ஒரு நிமிஷம் காமிங்க sir.
what?
Last page ஒரு நிமிஷம் காமிங்க. Thank you sir.
See, oscillating charges means, so oscillating charges are nothing but accelerating charges. Oscillating charges are accelerating charges. So when a charge gets accelerated, it produces oscillating electric field, oscillating magnetic field, and this oscillating magnetic field produces oscillating electric field. So the important result of Maxwell's theory is accelerated charges radiate electromagnetic so accelerating charges radiate electromagnetic waves. This is an important result of Maxwell's theory. This is an important result of Maxwell's theory. So when we look at this name, electromagnetic wave. So we have three distinct terms here. That is, first one is electro, second one is magnetic, third one is wave. So everyone know about wave? What is a wave? Okay, fine. So here wave, in every wave there is a transport of energy and this happens without transport of matter. That means, suppose this is a ball, right? So if I throw this ball gets some velocity, okay, and it has some mass, so it also has some kinetic energy. How much? Half m v square.
MP square.
Yeah. So this ball travels from here to here, right? So here it has velocity v, kinetic energy half mv square, and mass is m. So here you can see that both mass of the ball and kinetic energy are traveling, right? Both of them are traveling. Is it clear? But in case of wave, if you see a wave, 1 minute. So look here, this is a traveling wave. So if you can see that here, you can see the blue color and red color, okay? So look here, look at this blue color ball. Initially it is here, right? Hello?
Yes, sir.
See, initially this blue color ball is here, right? So this is a point mass in this string, okay? Now, after some time, so initially it's here. Now this blue color ball is where it is coming here. This mass, which we marked initially, it came here. Now it's here, right? Now again it came to the second position. This is first position, this is second, this is third. Again it went to first. Now again it came to second, sorry, no, it came to third. Then again it went to second, it goes to first. Okay, so you can see the mass here. So this small point, it's actually moving up and down. Is it clear?
Yes, sir.
It's moving up and down. But if you look at this wave is traveling in which direction? This wave is traveling in
Linear direction.
that's what, forward direction or x direction. Is it clear? So
Yes.
this is a wave. So if you take not only this point, this blue color point, you take any other point. Suppose if I take this point, so if I take a point here, suppose if I consider a mass here, this mass, okay, so after some time this mass, okay, this point comes here, okay, that mass comes here, okay, so this is a wave. So actually here the mass moves up and down, but the energy moves in forward direction. Is it clear?
No, sir.
Not clear.
இத மட்டும் மறுபடியும் ரிப்பீட் பண்ணுங்க சார்.
See, in this case, this mass is moving up and down, right?
Yes, sir.
Yeah. But this wave is moving in which direction?
X direction.
X direction, right? This wave is moving in X direction. See, this is the specialty of wave. Okay, this particle moves in up and down direction. Wave travels in forward direction. Okay, that means see, in this case, mass travels in forward direction. Energy also travels in forward direction. But in case of wave, mass moves up and down. Okay, you take any point on this string, it moves up and down. Energy travels in forward direction. Is it clear? So wave is nothing but energy. Okay, so I'll take. Anyone have doubts in this?
No, sir.
No, fine. So this is
Page
yeah.
kondu kaatenge.
What?
Front page kondu.
This one.
Yes.
Yeah, nice. Now look here.
1 minute, sir. Okay, sir.
Now, equation of wave. Equation of wave. So, equation of wave is given by y is equal to a sine y is equal to a sine kx minus equal to so kx minus omega t. So what is it? Y is equal to a sine kx minus omega t. Meaning of this is so A is amplitude. Okay. Then X is direction of propagation of wave. Direction of propagation of wave. These are the two important points. Now look here. If you look at this, can you see the wave? So if you look at this wave, See, this is y-axis, this is x-axis. Okay. So this length from here to here, it is called as, okay, this length is A, which is nothing but amplitude. Is it clear, everyone?
Yes, sir.
See, this is the maximum point on a wave. So distance of the maximum point from the x-axis is amplitude. See, this is called as crest. Okay, this is called as crest. This is called as trough. So distance between a consecutive crest and a trough. Sorry, this is also crest. This is crest. So distance between two consecutive crests is wavelength. Okay, so distance between this point and this line, and so distance between this line and this line is called wavelength, represented by
Lambda.
wonderful. See, this length is called as this is called as amplitude, represented by A. Now this wave is traveling in which direction?
Forward.
X direction. Clear? It travels in X direction. Its
Forward
amplitude is in, forward or X direction. Its amplitude is in which direction? Y direction.
Y.
Yeah, wonderful. So we write equation of this wave as y is equal to a sine kx minus omega t. Is it clear? Y is equal to a sine kx minus omega t. So here you have to remember two things. Okay, here, since I have x, if I have x here, that means wave is propagating in x direction. If I have y here, that means amplitude is in y direction. Amplitude is in y direction. Okay, so if I have minus here, see, I have minus here, right? That means so since we have minus direction, sorry, since we have minus here, it means that wave is propagating in positive x direction.
So somebody unmuted, sir.
Who is it?
Yes, sir. Somebody got unmuted.
Please mute yourself. Hello.
படுத்து 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 வைக்கியா
Like I cannot mute him. Hello.
டெய்லி நைட் விளையாடும் டைசன்
Hello. Can you unmute yourself?
எந்திரி பக்கத்துல வந்து என்ன படுத்துறியே
Again. See, equation of this wave is given by y is equal to a sin kx minus omega t. So, see, if instead of y is equal to a sin kx, y is equal to a sin kx minus omega t, if I have y is equal to a sin kx plus omega t, what is the direction of propagation of wave?
So negative x.
Ah, yeah, nice. Negative x direction. Okay. If I have z here,
Minus that.
direction of propagation of wave is negative z axis. So this is okay, information on wave. So here we have to discuss about k and omega. So the equation of wave is y is equal to a sin kx minus omega t. In this, a is called amplitude, k is called as wave number. K is called wave number. Formula for k is 2 pi by lambda. So lambda is wavelength. Omega is called as angular frequency. So omega is called angular frequency, where omega is equal to omega is equal to 2 pi f, where f is frequency, c is velocity of wave. Formula for c is equal to nu f lambda or c is equal to omega by k. Okay, these are the four important formulas you have to remember. Next, so suppose
Sir, last page காட்டுங்க sir. Yes sir.
So suppose there is a wave whose equation is given by y is equal to z is equal to a sin ky minus omega t, right? So Here, so what should I write in red color box? Should I write X, Y, or
Y.
Z?
Y axis.
All right. See, look here. Here we have Z, right?
Let's.
See, here we have Z. So we have to write
Z.
here. So wave is propagating in which direction?
Y, sir.
Y.
Positive Y or negative Y?
Positive Y.
Y.
No, yeah, it's positive Y. So we have to write Y here. So in this case, wave is propagating in this direction. Is it clear?
Yes, sir.
Nice. Next. Any doubts?
No, sir. No, sir.
Now, in this case,
So wave is propagating in Y direction.
yeah, very good. Positive Y or negative Y?
It's
Negative
Y.
Negative Y, wonderful. That negative Y propagation direction, correct. Okay. Then, now in red color box, what I have to write?
X.
axis.
Yes,
Very good. In green color box,
Negative Y.
minus Y, and the
Minus-
wave is propagating in this direction, right?
Y direction.
Very good. Okay. See, this is information related to wave which we need now. Next. So we are discussing what we are discussing. We are discussing electromagnetic wave. So green color part is over. So what? So we have in electromagnetic wave, we have electro and magnetic. So a wave which has time varying electric field and magnetic field is called as electromagnetic wave. What is it? Electromagnetic wave. So a wave which has time varying electric field and so a wave which has time varying electric field and magnetic field is called as electromagnetic wave. So how is this electromagnetic wave is generated? So if you look at this figure, we already discussed that oscillating charge generates
Oscillating electric field.
Oscillating electric field.
very good. Oscillating charge, electron or charge, whatever, generates oscillating electric field. So this oscillating charge generates, see here red color line is the electric field. Okay, so this red color wave is the electric field. Is it clear? So
Yes.
this oscillating electron generates oscillating electric field shown by red color wave. This oscillating electric field generates
Oscillating magnetic field.
wonderful. it generates oscillating magnetic field. So this red color wave generates this blue color oscillating magnetic field. Is it clear?
Yes, sir.
So this oscillating electric field equation, wave equation, is given by oscillating electric field equation is given by Ey is equal to, see, in this case I'm speaking, okay, in this case Ey is equal to E naught sine omega t minus kz. Is it clear? Ey is equal to E naught into E naught sine omega t minus kz, where and, or you take it as x. It's okay. So Ex is equal to E naught into sine omega t minus kz. By is equal to B naught into sine omega t minus kz. Okay. So according to this, so what should I write in this here? So what is this direction? So what is the traveling direction? Two waves are traveling in which direction?
X-axis.
Read it properly. This one, or I'll write it as kz minus omega t.
So the wave is propagating along z direction.
Ah, that's it. Okay. Why? Because we have z here. Kz minus omega t. So here, if you see this, so for electric field, we have z here. Here also we have magnetic field z, and okay, and we have minus for both electric field and magnetic field. So here the wave is propagating in which direction?
Plus Z direction.
Positive direction.
Yeah, positive z direction. Now what is the, so in this box what I have to write?
X.
So x,
Very good, x. In this box,
y,
Y.
clear? So x, y, z. Okay. So this is how you have to, you should understand these directions. If you understand properly, you can solve any problem. Now look here. See this, can I say from the diagram electric field and magnetic field are perpendicular to each other?
Yes, sir.
Right? Electric field and magnetic field are perpendicular to each other. Okay. Now, so in this, wave is propagating in positive z direction, right? So electric field direction is, what is electric field direction?
x,
Very good. Positive x direction. Magnetic field?
positive y direction.
Very good. So, did you remember cross product? So, we'll discuss cross product. See, this is x.
Sir, can you show me the last page, sir?
Last page. This one.
So just for 2 minutes, sir.
Okay. Over.
Yes, sir.
So x direction is represented by I cap, y direction is represented by
J cap.
J cap.
nice. Z direction,
K cap.
K cap.
what is I cross J?
K.
K.
What is J cross I?
Minus.
Minus K. Okay. So there is no logic in finding this. You have to mark up this. So J cross K is equal to I. K cross J is
minus I.
very good. K cross J is minus I. Then K cross I is
J.
I cross K is
Minus J.
minus J. Nice. Okay. So you have to remember these results to solve the problem here. So direction of propagation of wave, direction of propagation of, here I think K comes, direction of propagation of wave is given by E cross B. Okay, here E is, so in, see, for this formula, okay, so for this formula, what is E? E is electric field direction. Is it clear?
Sir.
E is electric field direction. B is
Magnetic field direction.
that's it.
Field direction.
So this is important formula. Now look here. Now if we go to the previous diagram, here what is the direction of electric field?
Sir.
X. X.
Yeah, Ix correct. Nice. So electric field direction is, can I say it as I cap?
Yes, sir.
Yes, sir.
Magnetic field direction.
Y direction J cap, sir.
Oh, nice. So suppose we don't know the direction of propagation of the wave. Is it clear? So we don't know direction of propagation of wave. We want to find direction of propagation of wave. So what is formula for direction of propagation of wave?
E vector cross B
Vector cross
Electric field
B
into
cross B
magnetic.
vector.
Yeah, electric field direction cross magnetic field
Magnetic field.
direction. So here what is electric field direction?
I cap cross
cap.
J cap.
J cap. What is I cross J?
K
K
cap.
cap.
K. So direction of propagation of wave is
K cap.
K cap. That means K cap direction is
Z
positive.
direction.
Positive Z direction, right? So we already have that in the previous slide. Is this clear? Now if electric field direction is minus I, magnetic field direction is minus K. What is the direction of propagation of wave? Quick.
Plus J.
Are you sure?
Yes, sir.
Do it again.
Plus J, sir.
So plus J cap.
Plus
Got it.
J.
Look here. Here we have minus I cap. Then we have cross minus K, right? So minus into minus is how much?
Plus
Plus
Plus. So we have I cross K. So what is I cross K?
Minus J.
So I cross K is, so direction of propagation of wave is,
negative Y direction.
yeah, minus J. So if I have electric field as direction as J and magnetic field direction as minus K. So what is the direction of propagation of wave?
minus I.
Minus I cap.
Very good. Everyone, look here. Here J cross minus K, right? So take
Plus.
minus outside. We have J cross
K.
K. So J cross K is
I.
I. Nice. So J cross K is, so if you look at this table, J cross K is how much?
I cap.
I cap.
We have to substitute this. Fine. So J cross K, we have to substitute it as I cap. So we get the answer as minus I.
Minus I cap.
Minus I cap. Nice. Next. See, sound waves require medium, right?
Yes, sir.
Sound waves require medium to propagate. Sound waves require medium to propagate. Propagate means to move. But electromagnetic waves does not require
Any medium to
Medium for propagation.
Doesn't require medium, right? So velocity of electromagnetic wave is represented by C and is given by 1 by root mu epsilon. What is it? 1 by root mu into epsilon. Mu is permeability.
Free space.
Yeah, permeability. Epsilon is
Permittivity.
Permittivity.
permittivity. Okay. So this form. So if we want to find speed of electromagnetic wave in vacuum, we have to use C is equal to 1 by root
Mu naught into
epsilon naught.
epsilon.
Okay. Mu naught is permeability of free space. Epsilon naught is permittivity of free space. Okay. So velocity of light depends on mu and epsilon. Then see, these electromagnetic waves carry energy and momentum. EM waves carry
Sir, last page காட்டுங்க sir. Yes, sir.
See, EM waves carry energy and momentum. So in the previous chapter, okay, energy density in electric field is given by, like I didn't discuss this chapter, but I hope you are taught this concept. Energy density in electric field is given by half epsilon into E square. Energy density in magnetic field is given by d square by 2 mu naught. See here, E is amplitude of electric field. Is it clear? Amplitude of electric field. What is B?
Amplitude of magnetic
Of magnetic
Oh,
field.
nice. Now we have the equation, that last equation. What is it? Ex is equal to E naught sine kz minus omega t.
T.
What is E naught? E naught is
Amplitude.
very good. Whose amplitude?
Electric field. Amplitude of electric field.
Nice, nice. Amplitude of
Electric field.
field. What is K? K is wave number. Omega is angular.
Angular frequency.
That's
frequency.
it. So intensity of a wave is given. Intensity of wave formula is I is equal to equal to half epsilon naught E square into C. Okay, half epsilon naught E square into C. So this is RMS value. Okay, ERMS. So what is RMS value?
Root mean square.
Okay, so ERMS is E naught by root 2. Is it clear? What is ERMS? E naught by root 2. A minute, I have small doubt. ERMS is
The last page or Nisha Karni, sir.
okay. Last page.
Sir, someone has any doubt, sir?
Okay, 1 minute. No, I didn't get any doubts. In chat box, it's vacant, right?
Thank you, sir. Sir, copied.
Copied. Yeah, nice. So, guys, just I'm not clear whether this E and B value is RMS or amplitude. Just please don't write it. Tomorrow I'll clarify whether it's amplitude or RMS. Okay. So, but this is in intensity of wave here. This is ERMS. Clear? So what I'm saying is, please don't note it down. Okay. I'm not sure whether this is amplitude or RMS. Tomorrow I will clarify it. Next. So,
Sir,
yeah.
give the sum according to this, sir.
Yeah, I know we were. So equation of wave is given by equation of electromagnetic wave is given by Py is equal to 2 into 10 power minus 7 into sine 0.5 into 10 power 3x plus 1.5 into 10 power 11 T Tesla. Okay. So here first question is find the wavelength of wave second question is frequency third question is expression of electric field. No need of, don't find expression of it. Yeah, find these two. over so
Sir,
yeah.
frequency வந்து 1.25 sir.
No. Wavelength
Wavelength 0.5 into 10 to the power of 3 sir.
no. See, I'll do. See, we have to compare this equation with the equation by is equal to b naught sine kx plus omega t. So when we compare this with this equation, so we have to compare this equation with, so red color equation with green color equation. Okay, green color equation is our standard equation. So when we compare these two, we get b naught as how much? 3 into 10 power minus 7. What is k?
0.5 into 10 power 3.
Omega
1.5 into 10 power 11.
So what is relationship between k and wavelength? That is lambda.
2 pi by lambda.
Yeah. So 2 pi by lambda is equal to 0.5 into 10 power 3. So I can write it as 2 pi into 0.5 into 10 power 3 is equal to lambda. So 2 by 0.5 into pi by 10 power 3 is equal to lambda. So what is 2 by 0.5? 2 by 0.5 is 4 into pi by 10 power 3 is equal to lambda. What is pi?
3.14.
3.14 by 10 power 3 is equal to lambda. This is 12.56 by 0.56 into 10 power. So what is lambda from this? 1.256 into.
அதான் சார் நானும் சொன்னேன்.
Oh, did you say this? Fine. Sorry. Okay, nice. Frequency. So see what is, so we have angular frequency as 1.5 into 10 power 11. Angular frequency is 1.5 into 10 power 11 rad per second. So what is relationship between angular frequency and frequency?
2 pi f.
2 pi f is equal to 1.5 into 10 power 11. So f is 1.5 into 10 power 11 by 2 pi. 1.5 into 2 into 3.14 into 10 power 11. 1.5 ones are 1.5, 2.1. So 1.5 is 1.5, nearly 2. Okay. So we get 1 by 4 into 10 power 11. So 1 by 4 is 0.25 into 10 power 11. We get 2.5 into 10 power 10 hertz. You get the same answer? Did you say this answer?
No, sir. I said only frequency, sir.
Okay. So this is the value of frequency. Nice. Now look here. There is one more formula for velocity of light. I didn't write it. Velocity of light c is equal to E naught by V naught. Okay, this is another formula. What is it? C is equal to E naught by V naught. So for the same question, expression of magnetic field is given. We have to find expression of electric field, right? We have to find, we have to find expression of, do it. Take 3 minutes.
நான் ஆன் பண்ணல.
Sir, 60 sir வருது.
60. I want expression, not amplitude of electric field. 60. Expression.
60 into V by M.
60 V by M. Okay. So here, see.
Sine into
Sine into
0.5 into 10 to the power of 3x plus 1.5 into 10 to the power of 11, sir.
See, did you take 2 here? B naught as 2. Did you take B naught as 2? Did you take it as 3 or 2? I took here, it's 3. Fine.
2 தான், sir.
2. Okay, take it as 3. So what is value of B naught? 3 into 10 power minus 7. So K is 0.5 into 10 power 3. Omega is 1.5 into 10 power 11. First point, since magnetic, okay, here the magnetic wave is traveling in which direction? Magnetic wave is traveling in,
So negative x direction.
very good. Negative x direction. So electric wave also should travel in
Direction.
same direction. Is it clear? It should also travel in
Same direction.
same direction, that is negative x direction. So wave number for magnetic wave and electric wave should also be same. Angular frequency should also be same. So general equation of electric wave is given by, see,
P2.
see here magnetic field is in which direction?
Y direction.
Electric field should be in what is the direction of electric field here? See, look here, direction of propagation of wave is given by E cross B, right? Hello?
Yes, sir.
Yes, sir.
Right? So in our question, what is the direction of propagation of wave?
Negative x direction.
Very good. That means minus I. So we don't know the electric field direction, right? What is the magnetic field direction?
Y square. J cap.
J cap. So what is electric field here? What is electric field direction here? So that we get minus I here. Quick.
Minus K.
Minus I by
K cap.
K, yeah, it's minus, sorry, it's K. So electric field direction is
K cap.
K cap. Why? Because
K into J equal to minus I.
that's it. If we take minus K in place of electric field, we get it as I, which is wrong, right? So here electric field direction is Z direction. So we have to write it as Ez is equal to E naught into, see, the same term comes here, sine 0.5 into 10 power 3x plus 1.5 into 10 power 11 t. Okay. So how to find this E naught? We have B naught. So what is the relationship between B naught and E naught? C is equal to E naught by
B naught.
B naught. So E naught is equal to C into B naught. So we have one more relation, that is C is equal to omega by
K.
K. So what is so E naught is equal to omega B naught by K. So here E naught is equal to omega is 1.5 into 10 power 11, 3 into 10 power minus 7 by 0.5 into 10 power 3, right? So 0.5 ones are 3s are E naught is equal to how much? 10 power minus 10. So 90 volt per meter. This is the value of E naught. So here in place of E naught, we have to substitute
90 volt by
9. That's it. Okay. So this is, so here what we have to find? We have to find E naught value. Why? Because this and this are same. Any doubts?
No, sir.
no, sir.
So here important formulas to remember. See, direction of propagation is
E naught into B naught
no, E cross B.
into B.
Okay. Direction of propagation is E cross B. See here E and B are just directions. You have to write directions. You should not write magnitudes. Is it clear? You should not write E naught value, B naught value here. Okay.
Yes, sir.
Second formula is velocity of electromagnetic wave C is equal to E naught by B naught. So C is equal to E naught by B naught. Other formula is C is equal to omega by K. So if they give omega and K, if they give omega B and K, if they ask you to find E naught, you have to use these two formulas. Nice. So what are the other important formulas we had discussed? See, this is also another important formula of velocity of light. So velocity of light, this is in a medium. Okay, it is in a medium. This is in
Free space.
free space or vacuum.
Vacuum.
Next, this is over. See, just remember this table. You have to remember this table. Just mug it up. Just mug it up. Next. So what is the electromagnetic wave? Time varying, a wave which has time varying electric field and time varying
Magnetic field.
magnetic field. Nice. See this table, this is also important. So how electromagnetic waves are generated?
By oscillating charges.
Yeah, very good. By oscillating charges or accelerated charges. Okay. So electromagnetic waves are generated by yes. So this was proposed by whom? This is a important, result of Maxwell's theory. Just remember this. Okay. So thank you so much. Have a nice good night.
Thank you, sir.
Sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you,
Thank
sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.